Okay, so for 11.3, we're going to solve a system of linear equations, which is something that you're familiar with doing because you've learned how to solve a system in Algebra 1 and Algebra 2. But for the quiz next week and for this unit, we're going to learn how to do it a different way, and that's using matrices and determinants. So I'll give you a second to copy down the first example. The first thing we're going to talk about is how to find the determinant of a 2x2 matrices. So go ahead, take a moment and copy down what you see on the screen, and then we'll go through how to find the determinant. Okay, so the formula is really quite simple to find the determinant of a 2x2 matrices. So you have matrices that has 2 rows and 2 columns. That's why it's a 2x2. So what you're going to do is multiply at a diagonal. So you're going to multiply A times D, and then you're going to multiply B times C and subtract those two numbers. So for matrices A, I'm going to multiply 3 times 1. And then I need to subtract from that the product of 6 times -2. So 3 times 1 is 3 minus 6 times -2, which is -12. So that becomes a positive when you subtract the negative. So you would get 15. That's your determinant. And we'll talk about how to use the determinant to solve a system momentarily, but the first thing you need to know is how to find the determinant. So let's do matrices B together. Again, you're going to multiply. You have to make sure you're starting with A times D first. So it does matter. So you're going to go down diagonal first. So that would be 6 times 3 minus my up diagonal, which is -1 times 4. And that's 18 minus -4, which again becomes addition because you're subtracting a negative, and you would get 22. All right, go ahead and try to find the determinant for matrix C. So for matrix C, you should get -2. So if you get -2, you got the right answer. So again, we're going to multiply -4 times 3, and then subtract from that -5 times 2. So that is -12 minus -10, which becomes a plus. So your final answer is -2. Okay, so now take a moment and copy down the formula on how to use determinants to solve a system. Okay, so what you really, so go ahead, take a moment and copy down or take a screenshot of this page, and then we will start talking through it together in a few moments. Okay, so this is our system that we're going to solve it, but we are going to use Cramers Rule to solve it, okay? So what we have is a system of equation. And in our system, if we were to make a matrices, it would be a 2x3 matrices. So we have the coefficients of x, which are 3 and 6. And then we have my coefficients of y, which are -2 and +1. And then I have my constants, which are 4 and 13. So what we're going to do is find the determinant. First, we're going to find D. Matrix D is everything except for my constants. So I'm going to make 3 2x2 matrices. So for my first matrix for D, I'm going to find the determinant of 3, 6, and then -2, 1. So that's my first matrix. And then my DX matrix, I'm going to replace my X column with my constants. So for my matrix, my 2x2 matrix for my DX, I'm keeping the Y column, but replacing the X column with 4 and 13. And then for my DY, I am keeping the X column, which would be 3 and 6, and replacing Y with the 4 and 13. So what we're going to do is find our determinant for all three. So when I find my determinant, remember we're multiplying at a diagonal, so we're going to multiply these two. And then I'm going to multiply, so I have 3 times 1 minus 6 times -2, which is equal to 3 minus -12, which is 15. So keep that number to the side. We'll do something with that later. So now let's find the determinant for our X matrices. For my X matrices, I'm multiplying 4 times 1 minus 13 times -2. So that would be 4 minus -26, which is 30. And lastly, for my Y matrix, multiplying at a diagonal, 3 times 13 minus 6 times 10, 6 times 4. And that would be 39 minus 24, which is 15. So what do we do with these numbers? Okay, so X The solution for x is going to equal my dx divided by d. So dx is 30, d is 15. So that would be 30 over 15, or 2. So x equals 2. And then y, that is going to equal dy divided by d. So dy is 15 and d is 15. So that's 15 divided by 15, which is 1. So the solution to the system using Cramers rule, because that's the only way to get credit, is if you find the solution using Cramers, is 2, 1. That is the solution to my system. So we're going to do a couple more. We'll do 2 more, and then we will continue tomorrow practicing. Tomorrow we're going to do 3 by 3s, which is a little bit more complicated. So okay, so let's go ahead and copy down a second example. And let's try that again. So let's look at this example here. So go ahead and copy down this, and we're going to, again, solve it using matrices. So we're going to make three 2 by 2 matrices. So my coefficients for x are 1. My coefficients of y are 2 and -1, and my constants are 5 and 3. So my matrices would be 1, 1. If I were to make a 2 by 3, and then my y is 2, -1, and my constants are 5 and 3. So when we're doing our first matrix, we only use these 2. So we ignore the 5 and 3 for my D, for the D matrix. So we're going to find the determinant. I'm going to make all 3 of them just so we have them. For my DX matrices, I'm going to swap out that first column and use my constants, 5 and 3. So 5 and 3, that becomes my new first column, but I leave my Y column alone. But for the DY matrix, I keep the X column. So I keep my first column, but then the Y column is swapped out with the 5 and 3. So go ahead, take a moment and find your determinant for all 3. So you're just cross multiplying and subtracting the product. So for the first one, when we're cross multiplying, remember we're going to multiply 1 times -1 minus 2 times 1. And that gives you -1 minus 2, which is -3. So we're just going to leave that alone for now because we need to find the other two in order to find the solution. So 5 times -1 minus 2 times 3. That would be -5 minus 6, which is -11. And then for y, we have 1 times 3 minus 5 times 1, which is 3 minus 5, and that's -2. So your solution so x is equal to your dx divided by d, and y is equal to your dy divided by d. So both of our answers are fractions. So if you're thinking that, oh my goodness, I'm not getting the whole number, I must be wrong. No, you're right. So for x, I'm going to take -11 divided by -3, which is just going to give me +11/3. And for y, I'm going to take -2 divided by -3, which is just +2/3. So my solution is 11/3, 2/3. That is the solution to this system. So we will do one more for today. And the next one doesn't have fractions as answers, so let's go ahead and copy down this last example. Oh, sorry, this one does have fractions in it. But that's okay. I do think that is one of the benefits of doing it this way instead of doing elimination or substitution. So our answers will be fractions, but that is okay. A fraction is still a number, so we will go with it. So take a moment and copy down the example and try to set up your matrices, your 3 matrices. And then we'll come back together in about 5 minutes. Okay, so for our first matrices, we're only using the coefficients of x and y. So that would be 3, 5, -2, 10. For our dx matrices, we're keeping the y column, but then putting a 0, 4 in the position for x. And for the dy, we leave the x column alone, and then the 0, 4 moves over to replaces the y column. So when we find our determinant, We're just multiplying at a diagonal. So for our first one, that would be 3 times 10. So we have 3 times 10 minus 5 times -2, which is going to give us 30 minus -10, which becomes 30 plus 10, so we have 40. Because when you subtract a negative, it changes to addition. And for my dx matrix, I have 0 times 10 minus 4 times -2. So that would be 0 minus -8, which is 0 plus 8, and that gives us 8. And then for our last matrices, we have 3 times 4 minus 5 times 0, which would be 12 minus 0, or just 12. So my solutions, x is going to equal dx divided by d, which would be 8 divided by 40, which I do expect you to reduce it. So 1/5 would be the best answer. For y is going to equal dy divided by d, and that's 12 over 40, which can be divided by, see, what can we divide that by? 4. Wait, yeah, we can divide them both by 4. So that would be 3 over 10. So my solution using Cramers rule is 1/5 and 3 over 10. So when you take your quiz, if you solve it using any other method, you won't get credit. So it's important that you practice using this method to solve a system. So that concludes today's class, and tomorrow we're going to continue in 11.3.